Good morning, everyone. Welcome to the session on consumer products. And I just have a few reminders to read before the session starts. So there's some Massachusetts licensed site professionals and toxic use reduction planners that have paid to obtain continuing education credits for the conference. So just a reminder, if you're one of those folks, you do need to verify your attendance by checking in at the registration desk, and that's required 4 times a day. So it's first thing in the morning, before lunch, after the lunch break, and at the end of the day. And the Massachusetts licensed site professional continuing education credit certificates will be handed out at the end of the conference. NUMO will not give out a certificate to those who are not present at the end of the day to pick it up. And there's no partial credits for early departure. So please remember to do that. Also, please remember to fill out the evaluations at the end of the session. And I'll go ahead and introduce our first speaker. And the way we're doing this is each speaker will have a chance to run through their presentation. And then we'll do a Q&A at the end of 3 presentations. So we have 3 speakers today. I'll introduce each speaker before they go ahead. So our first speaker today is Mike Schade. He's the director of Mind the Store, which is a program of Toxic-Free Future, which is a national nonprofit environmental health organization. The Mind the Store program challenges the nation's leading retailers to transform the marketplace away from hazardous chemicals and develop comprehensive, safer chemical policies. Previously, Mike was the Markets Campaign Coordinator with the Center for Health, Environment, and Justice, a national organization where he led campaigns to phase out PVC, plastics, phthalates, and bisphenol A in consumer products and packaging. Before that, Mike was the director of the Buffalo office of a statewide environmental health organization. He has a bachelor's of science in environmental studies from the University at Buffalo and lives in the Hudson Valley of New York. Please welcome Mike.
Morning. How's everyone doing today? Hopefully y'all had your coffee and fully caffeinated and all that. So yeah, my name is Mike. I coordinate the Mind the Store campaign for Toxic-Free Future. For those of you that may not be familiar with us, we're a national environmental health organization. We're based in Seattle. We have offices around the country, and we've been around for about 40 years, and we work to protect the public from harmful chemicals used to make consumer products, packaging, built environment. And we work at the intersection of conducting research that we leverage to drive for policy change at the state level, the federal level, and in the marketplace. And over the last couple of years, for our Mind the Store campaign, which I coordinate, we've been working to engage the nation's top retailers to reduce and eliminate PFAS in food packaging. You may have seen some of the news over the last year of some of our successes in moving companies like McDonald's and Burger King and most recently Starbucks, who have all agreed to phase out and ban PFAS. Thank you. And you know, there's been a lot of, I think, positive movement in the food packaging space in the marketplace and at the government level. However, when it comes to textiles, particularly outdoor apparel, we feel that there's been insufficient movement to protect public health and the environment. So we've been shifting some of our public-facing advocacy recently to focus on the use of PFAS in the textiles industry. And today I'm going to talk about a recent study that we authored and published investigating the use of PFAS in common household textiles sold at major retailers. And that report here is called Toxic Convenience, the Hidden Costs of Forever Chemicals in Stain and Water Resistant Products. And over the last day, we've heard a lot about the environmental health and public health concerns with the use of PFAS and the toxic trail of pollution that it has left behind, contaminating the drinking water in communities all across the country and all across the world. And certainly the use of PFAS to make textiles are often added to impart stain or water resistance. The use of PFAS in the textiles industry is one of those contributors to this life cycle of pollution that is contaminating our communities, posing risks to workers, getting into the air, getting into our food supply, getting into drinking water. So I'm going to talk a little bit first about some of the reasons why we're particularly concerned about the use of PFAS in textiles. And then I'll talk about the recent study that we just published a couple of months ago in January, which, by the way, is available for free on our website at toxicfreefuture.org. So, of course, we know, from a lot of studies and reports that the chemical manufacturing of PFAS has had significant impacts on workers and communities, particularly downstream of major chemical manufacturing facilities like DuPont/Chemours in places like West Virginia, North Carolina. And these chemicals that are made in these facilities, which have unfortunately contaminated drinking water supply for residents downstream, some of these very same chemicals that they manufacture are some of the very same chemicals that are used, that are added to textiles to help make them stain or water resistant. How many of you own a raincoat? I'm sure many of you do. So unfortunately, many raincoats, for example, may contain two different general types of PFAS. May have a DWR treatment that is applied to the surface. And then also many raincoats, especially those like Gore-Tex, also contain a membrane between the layers to help with breathability. So there's different types of PFAS that are added to some of this outdoor apparel. And the manufacture of these chemicals takes place in communities, as you see here, which have suffered from contamination issues. Of course, it's not just the chemical manufacturers that are related to the textiles industry. We also know that there are pollution concerns associated with textile mills who actually apply the PFAS chemicals to fabrics. According to the US EPA, as you see in this quote here, the US EPA has documented that textile mills can discharge PFAS chemicals into wastewater, including legacy long chain PFAS. And unfortunately, there's insufficient monitoring of those facilities, and probably are in some places a source of pollution to be taking a look at. There have been studies around the world looking at PFAS pollution from textile mills. There was one study that was done in China a couple of years ago that documented PFAS discharges into wastewater. They identified elevated concentrations of PFAS in indoor air, raising concerns about occupational health exposures for workers. In fact, this one study identified that the concentrations of certain volatile PFAS that workers are exposed to was estimated about 100,000 times that of the general Western population. And of course, where do textiles get made? While some still today get manufactured in places like North Carolina, unfortunately, due to our globalized economy, a lot of that manufacturing takes place in countries like China and Vietnam, where pollution controls are woefully inadequate. There's also interesting research that has done that demonstrates that when we wear textiles, the chemicals are actually not always bound to the material. In fact, they can migrate out, they can volatilize into the indoor air. And there's been a couple of studies that have looked at this question of, when we wear raincoats, for example, when we are out in the environment, when we're going on our favorite hike, when we're, exposed to UV radiation from the sun, when it's humid and it's getting wet outside, what does that do? Do the PFAS chemicals stay? Well, unfortunately, there's evidence that when we're wearing these products, when they're exposed to UV radiation, humidity, one study actually mimicked common environments that you might find yourself in when you're out on your favorite hike. And they found that when they weathered the DWR coated rain gear with UV radiation and humidity, they found that pretty significant increased levels of both volatile as well as persistent PFAS. So in the case of the acids, they found that the concentrations increased by as much as 5 to more than 100-fold. And one of the things that was particularly interesting about this is they collected samples pre and post weathering, and there were compounds that were actually not originally detected before the weathering. So the weathering actually led to the degradation of the materials and the release of these acids at pretty significant concentrations. They also looked at concentrations of other volatile PFAS, and those increased as well by a factor of up to 20. So that's a concern for consumers, right? When we wear these products, there is some evidence that these compounds can migrate out, and that raises questions of when we as consumers wear these products, are we being exposed to them? There's some evidence that certain PFAS may migrate, can get into your skin. I think there's more research that needs to be done there, but certainly these chemicals are not bound to the fabric, to the materials, and when you're out on your favorite hike, you may actually be leaving behind a trail of pollution on the trail, since these compounds appear to be migrating out from weathering. Another study that looked at this question was published by a nonprofit organization in Michigan, Ecology Center. They worked with researchers at Indiana University. They looked at whether or not PFAS chemicals were present in infant and children's car seats. And they found that roughly half of the car seats that they tested, purchased in 2018, had PFAS treated fabric, which of course is a concern when you consider that infants, young children who are particularly vulnerable to chemical exposure are sitting on these products in particularly sometimes hot environments on a hot sunny day. They also looked at whether or not the concentrations of certain PFAS changed or not when they exposed the car seats to UV light. And again, they found that the concentrations of certain PFAS increased as a result. So consumer use, when we're interacting with textiles treated with PFAS, there's evidence that we may possibly be exposed to those substances, and they may get into the environment. And then also when we do our laundry, when you throw your raincoat or your hiking pants or maybe your tablecloths or napkins that are treated with PFAS into the laundry, unfortunately, there's also evidence that those compounds can also transform and migrate into the laundry water, make their way into wastewater, and eventually make their way into the environment, especially when we know that wastewater treatment plants do not do a very good job of capturing and treating PFAS. This table you see here is from a report published by the International Commission for Environmental Cooperation, which was created from NAFTA. And they conducted an experiment simulating laundering of treated jackets and different pants. And they found different PFAS compounds at relatively significant concentrations. So the use of PFAS in textiles in our homes is also releasing these chemicals into the environment when we wash these products. You see there, I think 4 or 5 different types of DWR or textiles with Teflon membranes that released various long and short chain PFAS compounds. Another study looked at whether or not microplastic fibers released by textiles contain PFAS, and they also found pretty relatively significant concentrations of individual PFAS compounds, and they estimated how much PFAS is released into the environment from these microplastic fibers, and they estimated in the European Union that rain gear contributes to as much as 2,000 pounds per year in the European Union alone. So the use of these products in our homes can also be a source of PFAS chemicals into the environment. And then, of course, when the products are eventually disposed of in landfills, we know that the compounds can migrate out, make their way possibly into groundwater or landfill leachate. So from production to use to disposal, the use of PFAS chemicals in textiles is contributing to the release of these substances into the environment. Now, we don't know what percentage, how significant, but we know that the textiles industry is one of the biggest users of PFAS, not only here in the US, but globally. And the fact that we're still seeing these chemicals in textiles is a cause for concern. Of course, we know that all of us are exposed to PFAS day in and day out from different routes of exposure. One of the things that we thought was particularly interesting is that there's been some studies looking at PFAS concentrations in indoor air at different retailers. Think of a retailer like REI who sells a lot of these products that are treated with PFAS. And researchers found that the concentrations of PFAS in indoor air at outdoor apparel retailers is actually significantly higher than other types of occupational environments. So this could pose some occupational concerns for workers at, say, an outdoor apparel retailer like an REI or Dick's Sporting Goods. We've done some research recently to look at whether or not short chain PFAS and also legacy PFAS are continuing to accumulate and appear in women's breast milk. Our science director just last year published a brand new independent peer-reviewed study that looked at concentrations of PFAS in breast milk. We collected samples of 50 random women from the greater Seattle area. These were just ordinary folks like you and I. These are not folks that lived near PFAS contaminated site per se. These are not people that worked in a chemical plant or another facility where there was known major uses of PFAS. And one of the things that was really interesting about this and quite shocking is that every single mom whose breast milk was sampled had measurable concentrations of different PFAS. We identified 16 different PFAS in that study, 12 of which were detected in more than 50% of samples. And of course, that's of concern given that moms who are breastfeeding may possibly be or likely are passing these chemicals on to their babies. Now, that's not to say that women should stop breastfeeding. Breastfeeding is still best for a baby, but this is a cause for concern that mother's milk, what should be the purest, safest food for baby, unfortunately is contaminated with these persistent legacy chemicals. And one of the things that was particularly worrisome is that, companies like Chemours and 3M have argued, well, the newer short chain PFAS are not going to build up in the environment. They're not going to build up in people. Well, unfortunately, we did find short chain PFAS in pretty much all the women whose samples we collected. We also looked at the literature of other studies that have looked at this question. We found that newer PFAS detections are doubling globally in breast milk every 4 years, which is certainly cause for concern. So that's all to say that we're very much concerned about the ongoing use of PFAS in textiles. So we conducted this study to get a better handle of whether or not companies are continuing to use PFAS in common household textiles. What type of textiles are they being used in? What retailers are selling these products? So we decided to focus on 3 different key product categories that all of us come in contact with on a regular basis. The first category is outdoor apparel. The second is bedding, sheets, comforters, and the third was tablecloths and napkins. We primarily tested products that were marketed as stain or water resistant because we particularly wanted to understand whether or not those products still contain PFAS, given that especially there's been a fair amount of market transformation over the years, but we wanted to get a sense of whether or not these chemicals are still being used and are present, and then if so, which ones are being used. So we collected 20 samples from each of these 3 product categories, so 60 samples in total. The products were purchased from 10 major popular US retailers. We collected samples of both private label and brand name products sold by these retailers. And they're companies that probably all of us shop at day in and day out. Amazon, Walmart, Target, REI, Dick's Sporting Goods, Costco, some of the biggest and most iconic retailers in the US. And with the testing, we did essentially kind of like a 2-phased approach. Yesterday, we heard some presentations that talked about the value of screening for total fluorine as a way to investigate whether or not PFAS chemicals are likely found. So first, we sampled all of the products for total fluorine. We sent them to a lab. And then for those products that had concentrations of fluorine at 100 parts per million or above, we then sent them to another independent laboratory, Eurofins in Sweden, and we had them analyze the products for 51 different compounds. Now, it's important to note that 100 parts per million isn't, there's no magic reason why we picked that number. Of course, higher concentrations of fluorine suggest greater chances that PFAS compounds are likely found. So that's not to say that products containing fluorine below 100 parts per million don't contain PFAS per se, but we just use that as a screening in our study. We're a small nonprofit organization. We can't test everything. Testing is expensive, so we use that as a cutoff. So for those products that had 100 parts per million of fluorine or above, they were then measured for these 51 different PFAS compounds, and we looked at a mix of volatile PFAS, such as the fluorotelmer alcohols, as well as the ionic PFAS, including long chain compounds like PFOA. Perhaps not surprisingly, unfortunately, most of the products that we sampled across the board did have measurable concentrations of different PFAS compounds. And one of the things that was really interesting is that for the products that were marketed as stain or water resistant, when I say marketed as, they'd have a little label on the product or on the website saying that it was waterproof or stain proof. That was clearly a good indicator of whether or not PFAS were present. We found 72% of products marketed as stain or water resistant contained measurable levels of different PFAS compounds. On the flip side, 100% of products that were not marketed as stain or water resistant did not contain PFAS compounds. So if you're a consumer and you're concerned about this, be wary of products marketed as stain or water resistant. On the flip side, 28% of products that we sampled marketed as stain or water resistant did not contain PFAS, which suggests that alternatives are available. Companies can make products to achieve water or stain resistance without the use of different PFAS compounds. Unfortunately, we found that PFAS present in at least one product from every one of the major 10 retailers that you see pictured here. So clearly this is a industry and sector-wide problem. Some of these companies are working, to their credit, to begin to tackle this issue. For example, Target has set a goal to eliminate PFAS in their own brand textiles by 2025. Some of the other companies have not yet meaningfully acted. We are an advocacy organization, so we've launched a petition calling on REI to lead the outdoor apparel industry away from PFAS. And I'm happy to share that since November, we've mobilized over 110,000 REI customers and members who have signed petitions calling on REI to lead the outdoor apparel industry and to phase out PFAS. Many of their suppliers are already moving. For example, Patagonia has a goal to eliminate PFAS in their products by 2024. So certainly if companies like Patagonia can do this, certainly REI can and should as well. So I want to now look at some of the product categories that we looked at a little bit more closely. Thank you. So with rain gear, we found that 75% of rain gear products, outdoor apparel, marketed as stain or water resistant, contain PFAS. So 15 out of 20 jackets, shirts, or pullovers and pants, 15 out of 20 of those contain different PFAS compounds. Now here is oh, the Zoom thing is blocking my slide, unfortunately. I don't know if there's a way to move that. But if you take a look at the top there, that shows, oh, thank you, that shows the FTOH compounds, the fluorotelmer alcohols. And one of the things that I think is really interesting about our investigation here is that across the board in many of the products, yeah. Sorry for the tech problems here, folks. You know what, I can manage. Oh yeah, thank you, good idea. All right. Now, how do I get back? Give me a second. All right, crisis averted, I think. Thank you, folks. So at the top here, you see the different fluorotelmer alcohol compounds that were present. The levels here are reported in parts per billion. And then at the bottom, oh, this thing is now blocking the other results. Oh my God. All right. Yes. Clearly we can use a little more tech help. But the thing that I think is interesting here is that we see that not only the short chain compounds, which are not too surprising, but across the board for most of the samples we collected, we found the legacy long chain PFAS compounds present in actually virtually most of the samples, which is very concerning here. We also see some of the acids present in many of the products, and some of the concentrations here are relatively significant. So for example, we see in this REI Gore-Tex jacket concentrations of PFAS over 1,000 parts per billion, including the long chain PFAS. And the thing that's interesting about that is that both REI and Gore-Tex have said that they have phased out and banned the long chain PFAS, yet our testing reveals that those compounds do remain still available in products that they sell. Here we go. So here the next slide shows some other examples of other types of apparel. Again, we do see mixture of long chain, short chain PFAS concentrations really vary from product to product. So again, in some cases, the levels are relatively high. This Under Armour golf pullover contained 1,400 parts per billion of 6,2 FTO. So definitely something to be concerned about. And a thing that I think is also interesting is that for most of the products, we often would detect not just one individual PFAS compound, but a mixture. And part of, I think, what we're seeing here is that some of the substances degrading and forming other PFAS compounds. We also found PFAS in most of the bedding products marketed as stain or water resistant, 69% of those testing positive. All 4 of the comforters that we tested contain measurable concentrations of PFAS, which of course is something that is worrisome, especially when we think most of us sleep 7 to 9 hours a night in a comforter, and some of these products seem to contain notable concentrations of PFAS. Again, in many cases, a mixture of both long and short chain. Similar results that we see here for mattress pads. Only one of the sheets that we sampled, it was actually a pillow protector. Only one of the pillow protectors that we sampled had measurable concentrations of PFAS. Again, relatively significant concentration, 600 parts per billion. And again, a mixture of different compounds. Another category that really surprised us and worrisome was the fact that we found most of the tablecloths and napkins marketed as stain or water resistant. 71% of those contain measurable concentrations of PFAS. Concentrations in the tablecloths generally were relatively low, although you see here this one tablecloth with over 2,000 parts per billion of 6,2 FTO. And then again, some of these other tablecloths containing mixture of different long and short chain compounds. We also identified different PFAS in napkins, which of course is worrisome when we know that, eating off of a napkin, it's touching your face, touching your lips. That may be a source of ingestion, which is worrisome. And again, the fact that we found so much long chain PFAS in the products we sampled was really shocking to us, quite frankly. 74% of PFAS containing items tested positive for long chain. In fact, in some cases, they were the most abundant or the only PFAS compound detected. This here is a little graph or table from our report. Those with the little circles indicate the products that contain the long chain PFAS compounds. The good news again is that for every single product category, all 3 of the product categories that we sampled, we did identify PFAS-free products. So the good news is that we don't necessarily need these chemicals in textile products to achieve stain or water resistance. So there is some good news, and this is my last slide here. So I want to talk a little bit now about, what can we do about this issue? It's a really important issue. We know that unfortunately, textile brands, retailers continue to use these chemicals. And in fact, this may actually be in violation of federal law. Some of you probably know that under TSCA, the US EPA set a significant new use rule in 2020, which actually prohibits the import of articles like textiles containing PFAS. We collected many of these samples in the fall and winter of 2020. Now, we're not saying that these products are in violation of the SNR. They may have been imported they may have been imported before the SNR went into effect. But the fact that we are seeing long chain PFAS being present in products that are being imported into the United States around the time of the SNR is certainly cause for concern. And I definitely think that if we have any attorneys in the room, that is something to look at, because it looks like some companies may possibly be in violation of the SNR going forward. So in terms of policy recommendations, we are working with partners and states around the country who are have legislation that is being introduced or being considered to regulate PFAS as a class in textiles. Some states like California, Washington State, where we're headquartered, have policies that are going through the regulatory processes, which may regulate PFAS in certain textiles. In fact, just this past week, the governor of Washington, Governor Inslee, just signed new legislation, which will likely speed up the time by which the state of Washington considers regulations on PFAS in certain textiles. Similar legislation or similar policies are being considered right now in other states like New York, California, Minnesota, and elsewhere. So we're hopeful that our study can help inform some of those policies. We're also working to advance more comprehensive governmental policies in states. A really great model that is out there is the Safer Products for Washington program, which in our view is one of the strongest state level policies in the nation that gives the state the authority to regulate and restrict classes of hazardous chemicals like PFAS. And we think that that policy, Safer Products for Washington, can really be a great model for other states. So if you're a policymaker, regulator, and considering policy solutions, that is something to take a look at. And then the final two recommendations for policymakers. One, we also need to ensure that communities that have been impacted by the life cycle of pollution need to be made whole. We need to ensure that communities are cleaned up. And we really need to be thinking not just about the legacy PFAS compounds like PFOA and PFAS, but we really need to be taking a class-based approach. The more we learn about short chain PFAS and other PFAS that have been introduced, the more we learn that many of them are also quite persistent. Many of them are also quite toxic. We're never going to solve these problems dealing with them one at a time. We really need to take a class-based approach and clean up the contamination to protect communities, especially environmental justice communities who are most vulnerable. And then the final policy recommendation is that state governments can also be a force for good in terms of leveraging their market power, their purchasing power. If you're in a state, many state governments spend millions, many cases billions of dollars buying stuff. So government agencies at the state level, at the local level, at the county level can leverage their purchasing power to reduce and eliminate the purchase of textiles containing PFAS as well as other products. So that concludes my presentation. I want to give a shout out to Erica Schrader, who is the author of this report that I just spoke about. Unfortunately, she couldn't be here today. Highly recommend you go to our website, picture there. You can download the report for free. There's a lot of other great information about it, including a short 2-minute video. And if you're interested in getting in touch with me, here's my contact information, and look forward to the Q&A. Thank you.
Just want to thank everyone for your flexibility with the technology. Just going to take a moment here to troubleshoot.
On that floating panel down on the bar that's floating in the middle of this side.
What, the black one?
Yeah, I know. I'm just trying to.
It should have a button that says high floating.
No, the problem is this touchpad. Yeah, it is.
High floating meeting doors.
Okay, perfect.
Yeah.
Yeah, it is.
Yeah.
Okay, thanks everyone. So the next speaker is Dr. Kate Crawford. She's an environmental health scientist and assistant professor of environmental studies at Middlebury College. She's an environmental health scientist who completed her PhD at Boston University School of Public Health and a postdoctoral research fellowship at the Geisel School of Medicine at Dartmouth. Dr. Crawford's research seeks to bridge the gap between environmental science and human health. Previously, she studied metabolism, disrupting effects of persistent organic pollutants in coastal estuaries, and ways that exposure to organic pollutants through diet affect perinatal health. One of her current research projects, which she will be speaking about today, investigates exposure to PFAS through ski and snowboard waxes. Welcome.
Wonderful. So thank you so much. Can everyone hear me in the back of the room? Awesome. Thanks for the thumbs up. And Mike, thanks for that wonderful setup for talking about ski and snowboard waxes. We're kind of continuing the theme in terms of thinking about PFAS that are found in outdoor recreation related products. So with that, let's think for a second about why people have these have PFAS in these ski and snowboard waxes. So broadly speaking, as we all know and have, if you didn't come in knowing this, now know it after having sat through a day of this meeting so far, PFAS are wonderful surfactants, which means that they're breaking the surface tension between water and whatever the other surfaces that that water is in contact with. So when you're thinking about skiing and snowboarding, you want to slide across the snow as quickly as possible. And so reducing the kind of surface tension between water and the snow and the ski base allows that sliding to happen more quickly. You can imagine this pretty kind of evidently from thinking about it in a competitive perspective, right? A racer is trying to get from point A to point B as fast as possible. And part of that is their training and their preparation that they've done for that race. But if there's an opportunity to gain a competitive advantage by somehow modifying your equipment, that's really desirable, right? Similarly, if you are a recreational skier or snowboarder and you maybe aren't as fit anymore as you used to be, like myself, you're really psyched to have these fluorinated waxes because they allow you to gain that feel of speed without being quite as physically active as you might have previously been in earlier years. So long story short, there's this kind of real user benefit that's being added by these fluorine or PFAS compounds in these wax products, which makes them desirable for the ski and snowboard community. For those of you who maybe have not spent a lot of time waxing skis, I just want to quickly introduce what this process looks like so that you can have a mental image of it as we go throughout this talk. You begin with ski wax products. There are a lot of different types that are designed for different snow conditions, different purposes, but you can see, I might be able to see right here, it literally says on this particular wax product, 100% fluorocarbons. So because of that, this is an actual picture of a wax bottle that I had a chance to take during a research project. So the labeling was there because, again, of these desirable properties that these compounds are imparting onto the ski waxes, and also because of the fact that these products tend to be more expensive than the non-fluorinated counterparts, and you needed to justify to the consumer why you were charging so much more money for these products, right? So people who do engage with ski and snowboard sports and waxing their own equipment tended to be familiar with the concept of fluorocarbons or fluoros in their wax products, though they didn't necessarily know what those compounds were, what the potential environmental and or health impacts were. They were familiar with this term, which will again come back up as we think about this research project. How do you actually then take this wax product and get it stuck to the base of a ski? Well, you have to somehow heat it into the base of the ski. That typically involves some sort of ironing process or creating enough heat through friction to adhere that wax product to the base of the ski. But in doing so, you almost invariably end up with more wax on the base of the ski than you want. Too much wax is actually slowing the ski back down. So you want to gain that kind of optimal wax amount on the base of a ski or snowboard. And sorry, you'll hear me say ski, I do mean ski and snowboard. As we go through this talk, you'll keep that in mind. So anyways, you then have to remove this excess wax from the base of a ski or snowboard, which you might do through brushing or scraping. And as you can see, these collective processes offer the opportunity for both volatilization as you're heating those compounds, as well as the generation of significant particulate matter in these waxing spaces that, of course, if you're using fluorinated wax products, have the potential to result in both volatilization of the fluorine compounds as well as generation of particulate matter that also contains those PFAS products. So the environmental and health effects aside, you're left with the ski base that nicely sheds water and allows you to glide really easily across the base of this or across the surface of the snow. This is what a typical wax room actually looks like. So you can see in each of these pictures, people have the skis flipped upside down and they're applying these waxes to the base of those skis. And they're doing so kind of in a confined space, not a lot of personal protective equipment or any type of effort to reduce exposure is really apparent here. And you can see that there's also a whole bunch of different types of wax products. Again, these are used and designed for different types of snow conditions and different kind of applications. So lots of kind of complex exposures going on in these scenarios, but certainly a lot of these wax compounds do actually contain these PFAS waxes or contain PFAS products. So at this point, people have started to investigate the environmental and human health impacts. So I'll start with the environment. At this point, research studies that have been conducted kind of around the world, Scandinavia, China, as well as in Maine, have documented PFAS in environmental media near ski and snowboard venues, things like snow, groundwater, soil, etc. And the concentrations in these locations tend to be highest at the start of the ski race course and diminish as you move along that trajectory of the race course, indicating that the wax is actually abrading off of the base of skis into the snow. These compounds that have been detected in these environmental media tend to be dominated by the long chain carboxylic acids. And we also know that they have been bioaccumulating in biota near these ski race venues, documentation in pine needles, worms, rodent populations in that vicinity as well. A little bit of it, research has also been done to look at human exposures to PFAS through these waxing activities. These studies have so far been limited to professional wax technicians in Scandinavia. So these are people that are waxing skis as their profession, so day in and day out, probably for many years at a time, potentially for World Cup athletes or professional athletes in Scandinavia. So pretty specific exposure scenario that isn't necessarily generalizable beyond that particular population. Nevertheless, these particular studies have documented incredibly high PFAS concentrations in these workers, and we'll see some data from that in just a second, as well as acute health effects that are resulting from these exposures. So again, as I mentioned, this really these high exposure levels, what this graph is showing that was published in Nilsson et al. In 2010 is looking at the concentrations of PFAS in the wax technicians as compared to the general population over here. And if you look at just PFOA, you can see that PFOA concentrations in these wax technicians' blood is quite a bit higher than in the general population. And while this study was limited to only 8 individuals, so it's a relatively small sample size, and therefore there was a tremendous amount of variability in the PFAS concentrations in those workers' blood, the range of these concentrations actually fall within the range of concentrations of PFOA in the blood of workers at a 3M facility where these products were made. So indicating that there's really high PFAS exposure within these highly exposed occupational populations of people. So we set out to do a research project to understand kind of how this context of human exposure to PFAS through ski and snowboard waxing relates to a slightly broader population. So specifically, we wanted to extend outside of Scandinavia. So we looked at skiers and snowboarders across the US, and we were interested in understanding intensity, duration, frequency, et cetera, of exposures to kind of capture the magnitude, so to speak, of those exposures. And we also wanted to expand beyond just these professionally exposed workers in this very high occupational exposure scenario. So we surveyed people that were just recreational participants, people who are amateur athletes, people who were involved with the ski and snowboard industries in some way professionally, but not necessarily as a wax technician, right? It could be just someone who works at a ski and snowboard shop or works for a ski club as the manager of the ski club in some way, but isn't necessarily doing a tremendous amount of waxing themselves. We also wanted to know, are people kind of aware of this by way of, are they doing anything to intervene with these exposures? Are they using any exposure reduction strategies while they're waxing skis? So we did this by way of an anonymous electronic survey, which we developed in the fall of 2020, and we piloted it with a variety of stakeholders, people within the ski and snowboard industry themselves, as well as exposure scientists and environmental epidemiologists that specialize in PFAS, to make sure that our survey instrument was going to achieve these research objectives. We asked questions about people's demographics, their sport affiliations. So we were specifically interested in learning whether people were involved with cross-country skiing, downhill skiing, and snowboarding, what roles they had performed within these sports and over what kind of duration of time. And again, we were asking about everything from recreational participation through some sort of professional engagement with these sports. And then also, of course, like, are they using waxes in their daily lives or ever on their skis, really? So during the winter of 2020 and 2021, we administered this survey by way of partnering with various professional organizations and industry groups to use their email distribution lists to send our survey out to a really broad population of skiers and snowboarders across the United States. We also enabled snowball sampling, which allowed user or participants of that survey to forward on a link to people who they also might think would be interested in participating in that survey, to again try to capture as broad of a range of skiers and snowboarders across the US as we possibly could. The inclusion criteria to participate in the study was broad. You just had to have been living in the US at the time of participation, such that you could provide us with an address in the US, and you just had to be affiliated with one of these 3 sports. So again, cross-country skiing, downhill skiing, and snowboarding. So this process resulted in recruiting 569 participants into our study, and they were from a pretty broad range of ages, which was perfect for our goal of capturing a really broad range of users of these wax products. And they resided in 33 US states, indicating that we'd done a relatively good job capturing a wide swath of the US population. Kind of consistent with the ski and snowboard community, they tended to both be relatively well educated and also of higher socioeconomic status. And they tended to be pretty healthy. They were both within a normal range of BMI or by and large, and also tended to be very physically active, again, kind of consistent with what you would expect from an athlete or people who like to engage in some sort of athletic activities perspective. When we look across the 3 sports that we were interested in capturing, we can see that there's pretty decent representation from each of these 3 sports. And a lot of participants participated in multiple of these sports. So they weren't necessarily a single sport participant, so to speak. We can see here that cross-country skiing is slightly overrepresented within this study, but generally speaking, again, we did do a pretty good job capturing all of these sports. So again, we wanted to know if people were waxing their own skis and therefore if they might be exposed to these wax products. So one of the first questions we asked was, have you ever waxed your own skis? That's shown here in this top bar. So the blue indicates they said yes to a question. The yellow indicates that they said no to that question. Excuse me, and any type of wax use was, have you ever applied wax to your skis or snowboards? So you can see here that about 92% of our participants said that yes, they had engaged with personal waxing activity. We then asked about the types of waxes that they were using, both waxes that do not and do contain PFAS. And what you can see is that about 67% of our participants actually said that they do personally apply fluorinated waxes to their skis and snowboards. I will make a quick caveat here to say that the way we recruited these participants by way of professional organizations, industry groups, and snowball sampling may have kind of oversampled for people who are more serious participants, but nevertheless, I think this is a really significant finding that a lot of people are in fact using these waxes. If you take just the people who said yes to using fluorinated waxes within their waxing activities, you can see that there's kind of an inverse trend with increasing fluorine concentration. So you don't have to know a lot about wax chemistry to appreciate the fact that low fluoro means less fluorine content in that wax. Pure fluoro is higher PFAS concentrations. But nevertheless, still about 35% of our participants were even still using personally these highest levels of PFAS waxes. So the key finding from this particular set of questions in our survey was that most skiers and snowboarders in the US do appear to be utilizing waxes on some level or around them in some way, including these fluorinated varieties. We then also wanted to understand kind of how long people are engaged with these sports as a proxy for kind of the duration of time that people might be being exposed to these waxes over. So here you can see that we've broken this down by a few different roles. So general participant is anyone kind of participating recreationally, but not necessarily falling within this either competitive athlete or industry professional category. And people tend to participate in these sports for really long periods of time. You can see that the median duration of time for downhill skiers, for example, is 31 years. So people are picking up these sports and staying in them for a long period of time, such that if they're using these fluorinated wax products, those exposures could be going on for many, many years. And we can see that even within these kind of more specialized roles within these sports, again, people are still participating for pretty long periods of time. So these lifelong exposures might be a problem. And then the last thing that we wanted to do was ask kind of how much people are actually waxing these skis. Like, are they kind of doing it once a decade? Are they doing it many times a year? And so what we see here is in the panel on the right here, that there's a pretty broad range of exposures in terms of how many pairs of skis and snowboards people are waxing. You can see that there are people who are waxing as many as 1,200 pairs of skis in a year. So just take a moment to think about what that means. That is 1,200 pairs of skis. And it's not that someone owns 1,200 pairs of skis, but it's that they wax a single pair of skis lots of times over the course of the season, right? So there's a pretty broad range of exposures. But even if you zoom into where the bulk of the data is located or the bulk of the responses were located, you can see that industry professionals tend to be waxing the most numbers of pairs of skis over the course of the year. So this makes sense and is consistent with that prior literature. But I also want to call your attention to this yellow box plot here, which is this recreational participant category, right? These are people who are not doing this professionally, but are just kind of like to ski or snowboard and are applying wax to their own skis. And so again, this is just fluorinated wax use. This isn't any wax use. So you can see that there's a potentially kind of real exposure amongst people who are just doing this sport kind of for fun. So while yes, the professional folks tend to be waxing the most skis, these recreational participant exposures are also real and concerning. As I mentioned, we also then wanted to know if people are using any kind of exposure reduction or intervention strategies. And so we asked about respiratory exposure interventions, specifically a variety of types of personal protective equipment, so respirators or face masks, as well as a few different types of institutional controls, a well-ventilated space or working outdoors, something like that. And this figure is set up like the previous one, where yes is indicated by blue, no is indicated by yellow. And you can see that this figure kind of looks the opposite from the wax use figure, right? Where there's many more no responses. So people don't seem to be particularly regularly using these respiratory exposure interventions. I will say that for each of these types of exposure interventions, there's slightly more yes responses in the fluorinated wax panel as opposed to the non-fluorinated wax panel, providing some sort of nod towards the fact that folks are aware of these exposures, aware of these concerns, and taking some steps to utilize interventions, but not necessarily as much as we might like, right? I want to also call attention to the fact that these people that tend to be working in well-ventilated spaces, if you're thinking about the home participant, that might look more like working in a garage with a window open or a room with a fan in it. It's not necessarily the type of well-ventilated spaces that we might think of from an industrial hygiene perspective. So in summary, we know that US skiers and snowboarders are being exposed to PFAS through waxing activities. These exposures are recurring repeatedly over long periods of time. They also tend to be highest amongst professionals, but these people that are just doing the sport for fun should also be considered in these considerations. And that while there's not a lot of current use of exposure interventions, I think it offers a real opportunity for kind of intervention and education amongst this community to do so more regularly. So we did have one additional kind of research question that came from a slightly tangential project that I just wanted to share with you briefly. We were also trying to understand what the concentrations of PFAS might be in these wax room environments to kind of try to tie back to some of those previous research studies in the occupational exposure realm. So we collected dust wipe samples from within a wax space to quantify PFAS exposures in those dust samples. So we did so by way of delineating surface areas within these wax rooms, specifically on a wax table. And we collected dust wipes both before and after a workday to understand kind of that accumulation or that utilization of waxes that occurred during that workday. We sampled at 21 locations. We currently have preliminary data for 8 of those locations. And while this isn't ready for prime time, I have a couple of wonderful research assistants that are working with me on this project at the moment. I did just want to kind of include the preliminary findings here to say that the kind of as a nod, I guess, to tying our data back to these previous research studies. So the 18 of the 40 analytes that we had analyzed are in fact detected above detection limits in these UX samples. And preliminarily, these concentrations are quite a bit higher than kind of other indoor environments that have been reported on previously, which makes sense given that we have a very known source of PFAS being entered or being utilized within these spaces. Also consistent with the prior literature, these long chain carboxylic acids tend to really be driving the mass of PFAS within these dust wipe samples. But inconsistent with prior literature on this topic, we're starting to find some of the replacement compounds in these dust wipe samples as well. Gen X was one of the most frequently or highest mass analytes that we were finding in these samples. So stay tuned for more of the details on this as we continue to work through the data, but just again, this really does kind of tie back into the previous literature showing that these exposures are real and high in the wax room environments. So with that, I would like to thank a variety of people who have made this research possible, notably the study participants for both the electronic survey as well as the dust wipe sampling, a variety of wonderful collaborators at the Boston University School of Health, the Geisel School of Medicine at Dartmouth, and also importantly, SGS Access, who did our dust wipe sample analyses for us. And also the wonderful research students who I mentioned have been working with me on this project at Middlebury College. So I look forward to hearing any questions that you might have for me after Catherine's talk, but I also wanted to just quickly put out a question to the audience in case anyone has any brilliant ideas when it does come back to the Q&A session. I get a lot of inquiries from folks within the ski and snowboard world now that they know that I'm doing this research that are, kind of, there's increasing awareness, right, within the general public of PFAS aren't great. And so there are these people, especially the kind of recreational participant category of folks who are like, wait, if this stuff is toxic, I don't want this in my house anymore, like get it out of my life. And so they call asking what to do with it. And I have been having lots of conversations with various folks kind of within the PFAS conversation, but I'm still searching for a really great answer to tell these folks. So if anyone in this room has an awesome idea, I look forward to hearing it.
Yes.
With that, thank you.
Great, thank you for that. I'll just take a moment to switch presentations again. Okay, and our final speaker is Rodgers. Catherine is a PhD student at the Boston University School of Public Health. She's presenting on work from her time as a staff scientist at the Silent Spring Institute, where she led work on exposures and sources of endocrine disrupting chemicals in the indoor environment. She also led the Institute's science translation for policymakers and governments, businesses, and community groups. Catherine Rodgers has a MPH from Boston University School of Public Health and a Bachelor's of Science in Neuroscience from Trinity College. Welcome.
Hi, good morning, everyone. It's great to be here. So thank you so much to Kate and Mike for setting up this talk. I think Mike did a really awesome job kind of giving an overview of PFAS in consumer products. I'm going to be talking more specifically about a research project that Silent Spring did that's also very similar to the research project that Toxic Free Future did, thinking about PFAS in consumer items. And really the project I'm going to talk about is thinking about, do product labels inform the presence of PFAS in products? So digging into more of that question about what do the labels about stain and water resistance say about PFAS in products? And this project is focused on, we focused on consumer items used by children and adolescents. And this project has been accepted for publication by Environmental Science and Technology, and it should be coming out soon. We'll try and let you know when that happens. Oh, wait, I need to get rid of this little floating bar again.
That damn floating bar.
Okay. Okay, we're good. Okay, and so yes, in my introduction, I'm going to be talking about work that I did as a scientist at Silent Spring Institute, which is a nonprofit based outside of Boston, and we research environmental chemicals and women's health. How do you get to the next slide? Is this the one? No, just the, and then if you go down there, sometimes there's some buttons that hover. Yeah, there we go. Okay. Okay. So the objectives of this work were to measure PFAS in consumer products that are used by children and adolescents. We also wanted to compare the concentrations of specific PFAS compounds and their precursors by using a total oxidizable precursor assay among our product types, and then evaluate whether marketing language can provide information about the use of PFAS in these products. So we had 8 product types that we tested that have a long exposure duration for children and adolescents. So kind of briefly, they were lumped into these categories of rugs, upholstery, bedding, sheets, mattress protectors, pillow protectors, clothing, which included school uniforms and also included face masks, cloth face masks, menstrual underwear, and miscellaneous infant products. So that's like the product types. And then across those product types, we looked for 5 label categories that they fell into. So first, we looked for products that were advertised as stain or water resistant that had a trademark, like Scotchgard. We also looked for product types that were advertised as stain or water resistant that did not have a trademark. Third, we looked for stain or water resistant products that had some kind of non-toxic or green language or a certification, such as Ecotex. Fourth, we looked for products that did not have stain or water resistant language, but that did have that kind of green language or non-toxic language or certification. And then lastly, we looked for products that did not have any markers of stain or water resistance or any of that green language or certification. And so within our 8 product categories, we tried to find products that met each one of these product or these label categories. We weren't completely able to do that, but that was what we set out to do. And then before I kind of dive into the methods, I just want to say then we used kind of a tiered measurement approach. We used 3 different types of analytical measurements. First, we used total fluorine. So as Mike said, this was also a method that they used. So the sample is combusted, and then an ion selective electrode then measures a total fluorine that's released from that combusted sample. We had 93 items in total that we bought that we screened for total fluorine. And for items that had multiple layers, such as a mattress pad or a face mask or menstrual underwear, we sampled each layer independently. So of those 93 items, there were 121 separate samples that were screened. Then our next tier of sampling was looking for 36 specific PFAS using an extended version of US EPA's 537.1 method, using methanol extraction and using LC-MS. So this wasn't, we weren't able to look for volatile PFAS. And so we used that method on the products that came back as having detectable total fluorine. And then adding in, making sure that we wanted to cover products that were in each of our label categories and product categories as well. So even if they came back, some categories came back as non-detect for total fluorine, we still wanted to make sure that we were testing across our range of categories that we had bought. And then our third approach was using a total oxidizable precursor analysis on products that came back as having detectable PFAS. And then again, also making sure that we covered the range of our product and our label categories. And so this is kind of, instead of doing like a weatherization, this takes the extract and oxidizes it, which kind of, in a way you could think about it as simulating weathering to an extent, and then measure additional PFAS that were present as precursors that we weren't able to get from the initial extraction. So here's just a table of the 93 products that were initially screened for total fluorine. So you can see, as I said, our goal was to find products in each of these 8 categories across our 5 label categories, but we weren't always able to, and it's kind of an uneven distribution. So the sampling was not representative of all products that children may come into contact with. But this is just to give you a sense of how these products were distributed. And this is a figure from our forthcoming paper that shows the findings for the total fluorine analysis, this first screening. And so these panels are organized by the label categories of being water resistant, to having green certification and then not having labels. And then the dots are colored by the 8 product categories that we tested. So the clothing kind of stands out. These red circles that have advertisements for being water stain resistant, including those that have green certification. Upholstery is also another thing that stood out to us. Rugs weren't always on the higher end, which is kind of interesting. And I should say the circles along the bottom of this graph are non-detects, or below 10 parts per million total fluorine. But it's just interesting looking. This also complements Mike's presentation. When you look at the two panels on the right, the products that were not advertised as having stain or water resistance, we saw fewer detects of total fluorine among those products, with the exception of, there's a few face masks, one that was high, and some upholstery items and a clothing item. So then we continue to do testing for 61 of those items that had detectable total fluorine for target PFAS analysis. So you can see in the red, these are the PFAS that were detected. Their chain length is listed in parentheses to the right of the compound. So largely represented by carboxylic acids. And then you could look on the right for the compounds in blue. Those are the PFAS that we did not detect. And sorry, under our detection, there were 2 FOCI compounds that were detected, but in our QC, they had pretty poor recoveries, but we're still reporting on those. And so when we look at our product types and some of the PFAS that were detected, these are just the 4 that were detected with the highest frequency. You can see that there's a range of longer, older legacy PFAS and shorter chain. And again, looking at pillow protectors, mattress protectors, those kind of stood out to us, along with clothing. And then of course, looking at the second column, there has the number of items that were tested. So there was one infant item. I think it was a pillow teether that had PFOA. And then again, in their target PFAS analysis, we only found PFAS in products that were marketed as stain or water resistant. So if you look at these bottom 2 rows here of products that were marketed as having kind of, a green language or some kind of certification, or not having any indicators of stain or water resistance or green certification, we did not detect PFAS. But you can see that on the top row here, looking at products that were marketed as stain or water resistant that had a trademark, unsurprisingly, we were finding some of these PFAS compounds. Now, this graph shows, this is kind of all of the results all together. So we'll take a minute to walk through this. The top panel here in the bars in gray show total fluorine in parts per billion. And each column corresponds to a product. So these are in our supplemental information that kind of, says what those are, but basically R is rug, M is mattress protector, et cetera. But all of these columns line up on top of each other from the top panel that has total fluorine to the bottom panel that has our target PFAS analysis and our oxidizable precursor analysis. So if you look at the bottom graph now, these are all the PFAS summed together. The orange on the bottom part of the columns show the sum of our target PFAS analysis. And the purple on top of that shows the sum of the PFAS detected from our top assay, looking at the precursors. So this is really interesting, and you can compare these two panels. They're in the same units, but you'll notice that the scales are very different. So by and large, the total fluorine that we were detecting wasn't explained by our target PFAS analysis or the top measurements or the precursor measurements. And in addition, the precursor measurements, for most of these products were much higher than what we were able to measure with just doing our one round of extraction and measuring for PFAS. So this raises a lot of questions. This is really interesting. And some of the limitations I think that have already been hinted at are that, we looked for 36 target PFAS and a smaller subset of those in our precursor analysis. And we weren't able to, or we did not analyze volatile PFAS. So this is looking at ionic PFAS. So the strengths of our study is that it had a unique study design that allowed us to really think about the value of information on product labels for someone's ability to then avoid PFAS. We tested a broad array of products that children and adolescents come into contact with. And then additionally testing for precursors also provided data on a large range of PFAS. And the limitations of a total fluorine analysis is that it might include inorganic fluorine, so it captures both organic and inorganic. As I've already said, we didn't test for volatile PFAS. And then as you kind of saw from our distribution of our product categories in our label categories, it wasn't representative. It didn't capture, all of the types of products that are available on the market that might have PFAS that children come into contact with. And then a one-time sampling approach might miss changes in formulation over time. So we bought these products between February and September of 2019, I think. 2020? Oh my God, of 2020. Time is weird. So we might be capturing, what the textile stocks that are available at that period of time. I'd also heard anecdotally that some companies, I'll just dive into one example. We were surprised to see a face mask that had such high levels of total fluorine without any advertisement of being stain or water resistant. And as I was talking to people, and maybe Mike was a part of this conversation too, I'd anecdotally heard that manufacturers were, because of supply chain disruption, were using textile, rolls that they had on hand. So that might also be something to consider. But just a quick conclusion, we found PFAS in children's products, commonly found in children's products. And some of the highest levels that we detected were in children's clothing and school uniforms. the products that had stain or water resistant labeling were more likely to have total fluorine, and they were more likely to have total fluorine above 100 parts per million. And I'm sorry I missed that on my slide, but I think that kind of complements, you know, what Mike was saying earlier about deciding some kind of threshold, some kind of cutoff to use a total fluorine analysis as a marker of PFAS. But that we still did detect PFAS under that range as well. So it's not a hard and fast rule. And then much of the, you know, extractable PFAS that we measured were PFCA precursors. But as you saw, a large amount of the total fluorine that we measured was not accounted for by your target PFAS analysis. And then interesting, we found PFOA quite frequently among our detected analytes. And this is interesting because, you know, under the PFOA stewardship agreement, you know, PFOA should not be, you know, imported as a compound, although clearly it's still coming in, being imported from products. So it's already into the formula in products that are on the market in the US. So that's a summary of our project. Hopefully I'll have a chance to share this paper when it becomes available sometime soon. And I look forward to questions.
Okay, is this microphone working? Can everyone hear? Okay, perfect. So I just wanted to thank each one of our speakers. And then if folks have questions, if you could raise your hand, we'll get this microphone to you so that the folks who are listening online. Okay, there's someone in the back.
Did you guys look at exposure pathway on any of the products that you tested? Did you look at exposure pathway or, like, you know, potentials for any of that to actually enter, you know, kids?
Come over here so we can talk to the microphone. We did not. We selected products that children would come into contact with, either, you know, through thinking about the dermal exposure pathway, like clothing, also, you know, volatile from these products as well. And so some of them, like rugs and upholstery, might more, you know, PFAS might volatilize or might be more of an inhalation exposure pathway, but we did not take it to that level of doing, you know, an exposure study.
Great. Yeah, I want to thank the speakers. Congratulations. Those were wonderful and enlightening presentations. I have a question. I guess it's more of a semantic question. And Mike, I think for you, but I would value the input of the other speakers as well. And correct me if I'm wrong, I saw on the slide that like one product out of every category tested was deemed to be PFAS free. So that's the semantic question. What is PFAS free? How do you define PFAS free? Is it the 100 part per million threshold for total fluorine? Is it non-detect for the 51 individual compounds?
No, that's a really good question. I mean, yeah, essentially when we say PFAS free, we're essentially saying it was non-detect for the 51 compounds. You know, we did find lower levels of fluorine below 100 parts per million in some of the samples, but that was more few and far between. And, you know, we suspect that that may suggest less intentional use and perhaps contamination in the supply chain. You know, I think you raise an important point that it can be difficult to say something is 100% PFAS free. Given that, you know, and as Catherine noted, you know, we used 100 parts per million fluorine just as a screening tool. It's, you know, it's not a guarantee that it does or doesn't contain intentionally added PFAS, but we did find a correlation that when we looked for products with fluorine above 100 parts per million, I think in all but one product, we identified at least one of the 51 compounds that we identified. But yeah, I think you raise an important point, which is how do you describe what is PFAS free, especially when there is widespread environmental contamination. So when we talk about it, we're really thinking of intentionally added PFAS in terms of the scope of the report. And I should mention, if folks are interested, if you go to the report, you can also, we have a spreadsheet that has the levels of total fluorine that were reported. In some cases, they were really high. They were 8%, 8% of the product contained fluorine. And for those products, we think it's largely because of the Gore-Tex-like membrane in those products. I don't know if you want to add anything or.
Great.
Yeah, and that's, that's going to be a barrier, I think, to enforcement of the regulations. In California, you spoke to intentionally added PFAS. That's a whole other discussion, is what is intentionally added, what is, artifactual.
Yeah.
But when the legislation says there's a ban on PFAS in AFFFs or in rugs, any analytical chemist will say that there's really no such thing as zero, right? There's only as low as you can detect.
Yeah.
So, there has to be some sort of definition amongst the manufacturers of textiles. I mean, you've got Okotex or Okotex that prescribes things, but until there's a definition, it's gonna be real hard to enforce PFAS free. And moving forward, that's going to be the holy grail for manufacturers, is to be able to put that label on a product and say PFAS free. So, but again,
Yeah.
Thank you for the presentations.
Yeah, and I would just comment that, that's a conversation that is very much debated right now in California. I know there's active conversations in California around, what is the threshold for that legislation being considered. And I expect we'll see similar conversations in other states like Washington. And I don't think there's an easy answer. I think it's a very complex question, and hopefully it'll be sorted out further in the months and years to come.
So we have a question that came in online. One of the reasons fluorine is added to consumer products is because it's effective at repelling grease, water, stains, heat resistance, etc. If PFAS is removed from the product, is it still effective at repelling grease, stains, etc.? How is it determined that the alternative product is as effective as the fluorine containing product? And I don't know who wants to take that one.
I'm happy to weigh in too.
Okay. Yeah, I mean, that's exactly right. There's a reason why PFAS are added to impart stain and water resistance. They do a good job of it. There are other methods that for textiles that can be used, such as the tightness of a fabric's weave can actually work to repel water. There's also, we found some of our mattress protectors that we tested that were advertised as stain and water resistant did not contain PFAS. They can be made with like a plastic liner that achieves that. And that gets into a whole nother discussion about plastics. But there are other alternatives that can be used. And I think, Mike certainly showed that there are, products that are, at least they're being advertised as stain and water resistant that don't contain PFAS. And I also think there is a life limit to your water resistance of your rain jacket. That PFAS doesn't stay in there forever. Like, it does degrade with heat, UV light, over time. The PFAS it does degrade.
Yeah, I would just add that, if you're interested in getting a sense of what alternatives are out there, we put together, kind of like a 1 or 2 page summary of different technologies, substances, chemistries that are out there that serve as alternatives. There was one study that did a green screen assessment. I see Mark Rossi here, of various alternatives, and they concluded that of the different alternatives that are commonly used, paraffin waxes were more preferable compared to some of the other chemistries. They got a green screen score of a benchmark 3, which is actually quite good. Whereas some of the other alternative chemistries like the silicone based chemistries did not fare so well in the analysis. So if you're interested in kind of learning about the alternatives, that summary we put together in the report has, I think, some useful information. In talking with, manufacturers, I mean, there's a lot of exciting businesses that are bringing alternatives to market. If you take a look at there's an NGO by the name of ChemSec, and they actually have a database of alternatives to chemicals of high concern. And there's a bunch of companies that are in the ChemSec alternatives database that I think are worth looking at. I've been talking with different companies recently about the solutions that they offer. And one company that has an interesting solution that sounds very promising is this company by the name of Green Theme Technologies, and they offer a hydrocarbon based alternative. And they claim that their alternative actually performs better than C6 chemistries. In fact, I know that they're in active dialogue with companies like Gore-Tex about essentially being a technology that can meet the stringent requirements of the Gore-Tex standard. So there are some really exciting, innovative alternatives being developed. I think one challenge we face, though, is that there's a lack of ingredient disclosure. Not all companies are actually being very transparent about what their alternative chemistries are. And there are third-party standards that are out there that are being developed, like the green screen standard for furnishings and textiles, that I think can be useful, so that if you're a business, if you're looking at alternatives, using a tool like the green screen can help you understand the hazard profile of the alternative that is being considered.
Can you spell chems, do you say ChemSec?
Yeah, it's CHEMSEC. They're a European-based NGO that works on chemical policy. And they have a database of alternatives to chemicals of high concern, which is worth taking a look at. It's called the ChemSec Marketplace.
Okay, we have time for one more question. I'm mindful of the time. So
Thanks. This question is for Kate Crawford. I think when you started your presentation, you identified something that we as researchers always have to keep in mind, that there is an appreciable advantage for the consumer with these products. And near the end of the conversation, you had said you have people who are asking, what do I do with these toxic things in my house? I don't want these anymore. But what are some communication strategies that we might consider for people who see this, for the skiers, the snowboarders in your cohort, that this may be, one more regulation, one more kibosh on a sport that is constantly being regulated by the Federation of Skiing? And how do we get the consumer to perhaps recognize, yes, there are advantages and disadvantages, and bringing on maybe the other half of the contingent of skiers and their families who maybe feel that this is undue burden on their small sport, like why us, and getting them into the conversation on alternatives that they could use too.
Yeah, great. Thank you so much for that question, Emily. I think there's so many things I could say in response to that, but I think in the specific case of skiing and snowboarding, which has been a really interesting angle for me on this research project, is I think skiers and snowboarders kind of tend to be a more health and environmentally conscious group of people to begin with. There's kind of climate change initiatives within the ski and snowboarders of protect our winters and things like that. Like there tend to be kind of more environmentally minded maybe than the average person. So there's a little bit more opportunity, I think, for consumer buy-in in this particular capacity. And when I say consumer, I mean consumer broadly speaking, both the kind of recreational participant as well as the the kind of business professionals that are engaged with these sports, but they're still consuming these wax products. And in that particular case, I think that people would be very happy to switch away from these fluorinated waxes. Anecdotally, many of the conversations I've had with people throughout the sports, if there was an alternative that they could turn to, they would be incredibly happy to do so. So I think it is that kind of question of what alternatives can we provide to them. As both Catherine and Mike had implied, there's a lot of kind of research going on to what these alternatives might be. I will say that the anecdotal evidence that I have about what is going into these kind of, again, as you indicated, the ski wax industry is being regulated, and actually like they would be phased out by now, except that the real-time testing that's required to monitor competitions, basically to enforce this PFAS ban, those technologies just haven't been progressing as quickly as people would like. And so they haven't been able to regulate them yet. But long story short is I think that the alternatives that are going into some of these wax products as people anticipate this ban coming eventually are some of these alternative chemistries that they were mentioning, things like siloxanes and other interesting chemicals, molybdenum, graphite, et cetera, things that are probably not actually going to be much better at the end of the day. They're just a different problem. And so I think it doesn't directly answer your question, but I think if we can give people a safer alternative, they'd be psyched to use it. And from my perspective, it's kind of educating and informing. I think there's a pretty good understanding within the ski and snowboard community. There's been a lot of conversation in public press, I think, about the environmental impacts, but less about the human health impacts. And so I think drawing people into that angle of this conversation will be a way to kind of hook them into recognizing that this has the potential to really impact them.
I just wanted to thank all of our speakers and give them a round of applause.